It's keyboard time. No, not B-chord time. We're talking about custom, mechanical keyboards. These keyboards combine the best of the old and the new, with nostalgic tactile feedback and clicky sound, while offering complete customizability in both form and function. The one I'm about to make is a 65% keyboard, or a keyboard with 65% the amount of keys you would find on a standard keyboard. I figured this was a passing grade, as some of these things don't even have arrow keys, or numbers, or letters. We start by making a wood glue sandwich for the case, since none of my wood is thick enough to house all the internal components. We got a drippy one here, so we're going to let this guy dry for at least a few days. While that dries, we'll make a router jig out of some scrap wood. I'm trying out a self-centering dowel jig to hold 4 pieces of plywood together. I've seen mixed reviews about these dowel jigs, but this seems to be doing an okay job. Make sure to test the jig before you use it. I did so off camera. The stock gets trimmed down on the bandsaw and placed into a rather precarious clamping assembly. Allow me to explain. This Game Workshop twister is basically 2 layers of clamping. On the bottom layer, the stock is pinched together by 2 pieces of plywood clamped laterally and then clamped vertically to the workbench. The top layer is set up the same way, but it secures the router jig in the center of the stock. If you don't have 5 minutes to spare, route the whole cavity at full depth like I did. But if you want to do it right, make several smaller, incrementally deeper passes until you hit your depth. This will prevent some nasty tear out. Since router bits are round and our cavity needs to be square, we must chisel out the corners by hand. Don't spank your chisel too hard. Now we do a test fit of the back plate. This is totally my first try, and I didn't have to make any adjustments off camera. Alright, first try. I referenced the holes in the plate to mark where the screw holes are located. The PCB will have to sit up off the wood, so I'm using nylon risers to keep the circuitry elevated. These will also provide the screw holes. I didn't initially cut the stock to size so it would be easier to route the cavity. Now that we know the cavity is the correct size, we can mark and cut the walls to desired thickness along with the angle that makes the whole keyboard tilt forward. The bandsaw leaves a nasty finish, so we'll clean that up with a baby airplane. End grain gets the belt. The edges get softened up with a file and sandpaper and whatever else you got laying around. We have to cut a notch out of the stock to accommodate the USB port that sticks out of the PCB. This is done between a hand drill, a chisel, a file, and a little trial and error. Test and see that your USB cable fits. This thing is basically done, so it's on to the final sanding before it gets oiled up. I'm trying boiled linseed oil. Several coats while sanding at 400 grit should do. I avoid getting any oil in the cavity, but this will still have to dry until you can't smell linseed oil anymore. This should be a few days to a week, weather and heat permitting. You don't want it soaking your electrical components. We need to play operation with the PCB to make sure it isn't defective, and I really hope it's not because it took like a month to get here. Good enough. The wider keys all have their own key stabilizers that need to be put together. The key switches snap into the back plate and the PCB snaps into the key switches from the other side. If the metal contact points aren't straight, it won't fit. Each post gets a dab of solder. Not too much, not too little. It may not be a bad idea to test it again at this point to make sure you didn't fry the PCB on accident. I didn't. Before we put everything back together, we add a coat of paste wax to the case. Now we throw it all in the case, screw it down, and start popping some keys on. Okay, now it's time for the final test. You see, it worked for a little while, but then the keyboard bricked itself during an unfilmed test session. I honestly don't know what happened exactly, but the keyboard stopped working altogether. I looked into it, and the best I can figure is I accidentally ejected it when it was in a drive mode state. I guess this causes some combination of corrupting the onboard software and your Apple adding hidden files that aren't supposed to be there. I don't know. The same thing can apparently happen if you do a botched job of reprogramming your keyboard. So to solve this problem, you simply have to erase all the files that are on the keyboard and load the original software. Simple enough, right?
No!
Fixing this thing, Oh my god, it was so stupid. It's not worth going into detail over, but I'll give you some of the highlights. Conflicting information. Outdated OS tips. Overbearing Apple security protocols. Copy and paste how-to. Linux. Mac vs. PC. Terminal hoop jump. ICP doing the same thing over and over Arduino. Guess sabotage. Manufacturer. In the end, fixing the thing came down to two key turning points in troubleshooting. You have to write and erase files in Terminal because doing so in Finder adds more hidden files. Terminal wasn't letting me access my keyboard in drive mode. I eventually noticed in Finder that when the keyboard was in drive mode, it had 2 extra spaces after its drive name. Deleting these allowed me to finally talk to it in Terminal. The software I was trying to reload onto the keyboard just wouldn't work, even though it was the file in question on the majority of the troubleshooting forums and guides I could find. So eventually I tried something that was supposedly the default software, even though it had a different name than the default software. And just as soon as it had all come crashing down, it was working again. Before I wrap this up, I'd like to mention that in light of these events, there was an oversight in the case build. On the back of the PCB is a button that will put the keyboard in drive mode, allowing you to write and erase files from it. Adding a hole to access this in the case means not having to pull the whole thing apart if something like this should happen again. Also, the color keycaps I bought didn't all fit my keyboard layout, so I bought a bag of random keycaps off of eBay to fill in the missing keys. If you want to try building one of these things yourself, I'm going to leave links in the description for all the parts I had to buy, along with some helpful resources that really helped me wrap my head around this thing before I got started. Now obviously I built my case, but there's really no end to pre-made case options out there as well. All in all, this project cost me around $150, but it's not to say that you couldn't pull this off for cheaper if you wanted. Or more. Anyways, that's it for today. Thanks for watching. I hope you enjoyed this video, and I'll catch you on the next one.